Okay, so the only thing from this problem, if I remember correctly, we did finish it last time. This is the last example we did that we finished with the bicyclist. And I do remember I got the answer down here wrong. I mean, the quotient here is correct. Wait, let me get the laser thing. Again, if you can't see the notes, please, or you can't hear me, please say something, okay? So again, I know the quotient is correct. This number I think was wrong. I don't know how I missed it when I was going through the notes. I do apologize for that, but I fixed it now. Whoa, sorry. Uh-oh. Sorry, wrong button. I dropped something when I was lecturing. So again, this number is correct though. Okay. Sorry, I was trying to move something and I slipped that in my hand. My mistake. All right. Anyway, so, this is the answer. Okay. Now remember, the way we actually did this is again, remember the factor label method, right? Basically you're just using some kind of conversion factor, which is a fraction. And to convert it, you just basically multiply, right? And you want units to cancel, okay? That's the whole point of this. You want units to cancel. And what I was trying to show you before is, I don't think it's on these slides, I don't want to go looking for it, but if units do not cancel, sometimes you may have to flip the conversion factor or the fraction you're multiplying by. I mean, that's what the factor label method is. It's actually based on something, I think it's called unit analysis, if I remember correctly. And another way to solve these kinds of problems, we will see that today, is using proportions. Basically, you have two ratios equal to each other. So let me get to the next set of notes, and we'll do that now. It should be coming up. Oh, there it is. And these are the notes I emailed you got everyone today. All right. So basically here, what we're going to look at are rates. And a rate is actually a special kind of ratio. A ratio, remember, that's up here. It's just really when you're comparing two quantities. That's what you can do in mathematics. You can compare, and you can form what's called a ratio, which you can write as a fraction. That's one way to write a ratio. And a rate is actually a special kind of ratio. It occurs when the two quantities you're comparing are of different types. Like when you're comparing miles to hour, that's distance to time, or dollars, currency to weight. Those give you rates. I don't want to get too much into when a ratio is a rate and when it's not a rate, that kind of thing, because that's deviating from the core. That's going off tangent, excuse me. Instead, I just want to focus on rates. We also saw unit rates. And a unit rate, as we know, that's just when the denominator is 0. And as I said before, we can express ratios as fractions. That is something we can do. We can express ratios as fractions. And we actually do see these in the world around us. Like, again, when you're driving a car, right? You see the speed limit sign that says miles per hour. Like the speed limit is, I think on campus, it's like 25 or 20 miles per hour. That is actually a rate. In other words, it's a unit rate, actually, because the denominator, even though I didn't write a 1 here, it's understood to be 1. Like 1 hour, 25 miles over 1 hour. You can also write this with the 25 in front. Just like with other, we can do that, okay? We can write the 25 in front. Same thing with here, dollars per pound. You know, if you go to Walmart, let's say, and you might see that, oh, bananas are, I don't know, at $2 per pound. I don't know if they're that price, but what does that mean? What is $2 per pound? That's a type of unit rate. You know, for every pound of bananas you buy, it's going to cost you $2. So if you buy 6 pounds, I mean, I don't know how many bananas that is, but, you know, that would cost you, you know, some money. And you can also write these rates this way. Actually, it would cost you 6 pounds. That would be $12, I think. Anyway, you could also write it a rate. You can invert it like this. I mean, it's not a unit rate anymore. It's still a rate, though. 1 hour over 25 miles, or 1 hour per 25 miles. Okay. So that's actually what we have here. Now, we did do some examples last time, and I really just want to go through those examples again, because I felt like I could have done a better job explaining it. And again, if I go too fast, you know, don't be afraid to speak up. Remember, I can't see the chat. So, you know, speak into your microphone, okay? Or whatever. But let's suppose my car, I'm able to drive 300 miles on a tank of 20 gallons. You know, like when you're buying a car or getting a used car or whatever, you might hear about miles per gallon. And what I do know is the car I have theoretically can go 300 miles on a tank of 20 gallons. So first, I want to express this as a unit rate. So we're basically going to express this as a rate, and then we're going to do a little arithmetic to make it a unit rate. And that's what I'm doing here. 2 is also here. 2 is, part 2, how far can I drive on 35 gallons. We'll see that shortly. For number 1, we have 300 miles over 20 gallons. We write it as a fraction, a wonderful fraction. We write it like that, okay? Now, we want this to be a unit rate, correct? Okay, what I'm going to do is I bring the 300 in front and the 20 in front. It's kind of like what I did over here with the 25. I put the 25 in front. I'm basically doing that for the 300 and the 20. So we have 300 over 20, as you can see. We have miles per gallon over here. What's 300 divided by 20? You know, if you do that in your calculator, you should get 15. So we get 15 miles per gallon. Over gallons, excuse me. Which is the same as this. This is a unit rate. Remember, this is the same as 15 over 1. Right? A number itself is the same as the number over 1 as a fraction. So we have a unit rate. So we have our unit rate. Okay. For number 2, we want to know how far can I drive if I have on 35 gallons. So let's say my gas tank can hold more than 35 gallons, but there's only 35 gallons of gasoline in there. How many miles could I drive? That's really what number 2 is asking us. We can get that using the factor label method. Namely, we have our rate. See? So I have the rate, and we want to know how far we can drive on 35 gallons. So in other words, if we have 35 gallons of gasoline, how many miles can I drive? So if I have 35 gallons of gasoline, how many miles can I drive? Well, what do? We multiply. So that's all it is. And again, we did this right because we have units canceling. Namely, our answer, we want it to be in terms of miles. So we don't want that gallon unit there. And by multiplying like this, it does cancel. Right? This is on top, this is on bottom. These cancel. You get 15 times 35 miles, and that's 525 miles. And that's really the whole idea of the factor label method. right? Again, maybe this will help also. Let me just do this. When you have a number itself, right, that's the same as dividing it by 1 as a fraction, right? So we have this on top, the numerator. This is in the denominator, multiplying. So yeah, we're going to have cancellation. Okay, now before I go on to 3, are there any questions on this? Okay, for number 3, it's a little bit different, right? Because here, we want to know how many gallons do we need to drive 30 miles. So instead of having 35 gallons, we have 30 miles, so to say. And we want to know how many gallons of gas we need. So we want to know how many gallons of gasoline are needed for us to drive 30 miles. Well, if we were to, let's say, without thinking, multiply by this rate, the same rate we had over here, it is the same, remember. In the denominator, we have a 1. I mean, here we had gallons. Here we have gallons, or gallon, but it's okay, it's the same thing. But if we were to multiply, there's not going to be cancellation, right? Because again, the 30 miles and miles, they're both in the numerators. So you're going to end up with this. There's no cancellation here. Again, right? This is in the numerator. This is in the numerator. So you're not canceling, you're multiplying them together. We're not canceling, so something went wrong. We don't want our answer to have gallons and miles squared. We want our answer to only have miles.